Okay guys, I'm going to go over parasitic draw or what you can do with the PicoScope while doing a parasitic draw and kind of the cool features. First thing I want to show you guys is you can get these shunt resistors online. I can't show you this on the video, too hard to read. This is a 0.1 ohm resistor. They look like this. You can get them on Amazon or wherever. This one is a 100-watt resistor, so something to watch out for. I'll go over that here in a second. Is the wattage rating of the resistor. This one will handle safely about 8 amps, and the first parasitic draw that I did ended up being like 12 amps, and those things will get real hot. So you can get a much larger resistor. This one is rated at 300 watts, which is 24 amps. So it'll safely handle a higher load so that we can measure our parasitic draw and not worry about burning up a resistor or something. I'll show you how to look at wattage and what all that means, and just things to look out for when you're getting your tooling to do such tests with the PicoScope. So over here, let me pull up Ohm's law. All right, so here's Ohm's law. You can look at this for the guys that aren't familiar with this. These would be like a fraction, so volts divided by resistance is going to equal your amps, and same with volts divided by amps will equal your resistance. And then when you're going across your multiplication, so amps times your ohms will equal your voltage. That's basically Ohm's law in a nutshell. And then the reason I pulled this one up is because I was showing you how to calculate, wattage. So you literally, I'm doing like, take your average battery voltage of say 12.5 volts, just to make some round numbers, and you can take your wattage rating on your resistor and you can divide your watts by your voltage. Will give you how much current that resistor is basically rated for. So real quick and easy. So here's my 100 watts divided by 12.5 volts gives me 8 amps. Same here, 300 watts divided by 12.5 volts gives me 24 amps. That's basically how you're looking at what wattage rating you're wanting for what you're doing. If you expect more than 24 amps, most of us don't have that. You want a higher wattage rating. We're set up here. I'm going to give a quick little view of, I'm going to turn this camera around, what we got going on here on the car. Hopefully this makes sense. I know there's going to be quite the mess of wires going on, but from our negative cable, this one goes over to one side of our resistor, goes across our resistor to this jumper wire, which is going down there to our negative battery terminal, or it's literally just in series with our negative battery cables, so the current is flowing through this resistor. Then with the PicoScope, I've got the 2 leads off of my green channel A is measuring our voltage drop from here to here, just going across our resistor, because I know what the resistance of this resistor at 0.1 ohms is, which will allow me to calculate the volt drop. My red channel here, which is channel B, is just measuring battery voltage. We can kind of see the reaction of the battery voltage as we get a draw. So, get you set back up here. We're going to go over here to the computer screen. All right, so on channel A, we'll now do it over here. Channel A is literally just a voltage channel. I've got it set a sample interval of 1 second. There's no reason for high-speed capture here. Every second is taking a sample and it's going to graph it for us. I've got it at plus or minus a 5-volt range. I could probably dial that down a little bit, but that's good enough. We're doing a volt drop. We're not going to see, probably won't even see a volt. Okay, that's channel A. Channel B, just because I want to graph my battery voltage as this is going, and we can see as the draw comes on, you can watch a little bit of a dip in the battery voltage. Not really necessary, don't have to have it. I just like to, for demonstration purposes, but also visual purposes, and definitely not required. It's just a plus or minus 20 volt range, and also a 1 second sample rate. And then channel, well, it's not even a channel, it's a math channel that's set up. This is where we're calculating our amperage. And so here is, right here, where we've got our formula basically. So channel A is measuring our volt drop. It's going to be measuring in millivolts. So if you take 1,000 millivolts divided by 1,000, that'll give us 1 volt. The reason we need that is for the Ohm's law that we were looking at earlier. So voltage divided by resistance is going to be our amperage. So first it's going to take, channel A is going to take my millivoltage and divide it by 1,000 to change it to a voltage scale. And then we're dividing by the resistance of our resistor of 0.1 ohms. And then its output, return units, is going to be amps. And it's going to give us an amperage output. And so I've already have all this set up, but anyways, this is the only reason I use PicoLog, so this is always in here. And so that's my math channel right here, which will be the red trace. Once you're all set up and ready to go, we can start recording, and it's gonna, yeah, let's see, new data, yeah, start anyway. Erase what I got going. And now, yeah, no, let me start that over. That was a mistake. I should have hit the reset button. We'll start over. It'll ask another couple questions, you'll see. Okay, so I hit my little restart button. Now I'm going to tell it to start recording. And it wants to know local capture, so I'm going to save it on this PC. Continuous capture, which is actually kind of cool, because it shows it's gonna, could require up to a whole megabyte of drive space per day. So it's like, it uses no memory. It's like, okay, cool. So start my capture. I'll go over here to my graph button. And I'm gonna hit, hopefully it's there already, but this should follow all my new data. So it's gonna graph basically start to finish. It'll show it all on the screen. Currently we have, 9 milliamps. It jumps up and down. This is a live capture, just based on what's flowing through that resistor at the time. So now this is all going, I'm going to go over and open and close the driver's door. And you'll see everything wake up. You'll see my draw come on. Yeah, we're not following new data, you stupid thing. Show all data, that's what I wanted. And we missed. Yeah, it would have been, let me start that again. Dang it, stupid mouse. Pause, refresh, reset data. Start my capture. Okay. Everything's kind of going back to sleep again. And we can see that happening. Showing all data. Okay, so everything's going back to sleep. I just woke it up here. It's kind of going back to sleep, but I'm going to go and open and close the driver's door. And we will see as that happens. It'll capture it instantly. Opening and closing that door is waking up the body control module, all the buses, everything's waking up. So you can see our peak. We're currently drawing 10 amps. You can see, you know, the green trace, there's the voltage drop across the resistor, and then the red trace again is that math channel calculating our amperage. And you can see when everything woke up, you can see that yellow trace. It won't let my mouse show on the screen, but that yellow trace, you just see the battery voltage drop a little bit. And then it's just going to continue to capture and record as everything's happening on the car. You can watch it go to sleep. Now the advantage of doing it this way, if you've got one that's a very intermittent draw, you can put your voltmeter on it and you can do your min-max settings. But the way that works is, say I had a 10 amp draw right there because the body control module woke up, large draw that you weren't expecting to see, and your meter recorded that as your maximum, say just 10 amps. And so the max recording on your meter is going to be 10 amps. Now say 30 minutes down the line, your actual draw comes on and say it's 500 milliamps, half amp. Your meter won't record that on the max setting, the min-max, because you've already set a 10 amp draw. So it's going to tell you the highest draw is 10 amps. It's not going to tell you that you had a 500 milliamp draw come on. And so your meter, you know, min-max is just that. It's recording your minimum, your lowest amperage reading, and it'll record your highest amperage reading and nothing in between. This is graphing everything that's going on this car. So if this thing, I'd like it to go to sleep a little bit more, but I'm going to try to just maybe turn on, see if I can reach inside the car. I'm going to turn on just my park lights. Hopefully that doesn't wake anything up. Okay, park lights are on. But we're at 9 amps anyways. It's less than what it was before. I might have woke up the BCM. I was trying to get a little bit, you know, like a 500 milliamp or something come on. Turn my lights back off. And even on this example here, you'd be able to see, you know, where your meter's not going to have captured that second draw, because your meter's going to say, hey, we had 10 amps or 12 amps, whatever. It looks like I peaked above 13 amps. So your meter would tell you that one, but it's not going to show you any other subsequent draws that occur over the course of however long you're recording with your meter. So the meter is good, but it doesn't show you nearly as much as this does. This tells you everything that happens. The other nice thing about this is I can let this record all weekend. And I could come back and it will tell me everything that happened over the weekend. Did I have a draw come on? Did I not? How long did it come on? How many times did it come on? It just gives you more insight as to what is or is not happening on a parasitic draw. I've had lots of cars come in and it's so difficult to duplicate. And so you can just do a long capture over a long period of time and say, hey, look, this car didn't do it for 10 hours. I recorded for 10 hours. We didn't have one draw. Or if you did, it would have captured it. And then you would know how many times, you know, did it take 3 hours to occur and then it started occurring every 10 minutes. It gives you insight that your meter just can't do. Another cool feature, which I've not used, I've seen it used, I've not done it myself, I've not had a need, is PicoLog will actually let you put what you're capturing right now out on the internet. And say you're at home, you've got this thing running at work, you can log on to the website or however that works. I can't really tell you because I've not done it. But you can log on at home and pull all this up and see what your car is doing at work. Like, has it had a draw? Has it not had a draw? So this is the power of PicoLog and using the PicoScope. PicoScope does not measure your current directly, right? So we're doing it through a volt drop over a known resistor. So the car stays powered up the whole time. And obviously you can monitor for a very long period of time, but you're not directly measuring the current. We're doing it with the math channel and volt drop basically out, whatever. So let me get this thing to, we'll do it one more time, see if I can get something. Maybe I can, with my other window open, and turn a little light on or something. Okay, I'm gonna turn on the vanity lights on the passenger visor and see what that does. Very, very little actually. We're 480 milliamps, got a half amp draw right there. And so it's measuring that as well. And I'll walk back here. I'm gonna shut that, turn it back off. Okay, that light's back off, and we'll come back over. Yeah, you can see instantly right there. Let me stop this capture so we can have a cursor on the screen, or I'll pause it. No, you're not gonna let me? Fine. Okay, restarted the capture. Now it's showing the where I paused and then restarted. There's no data in between. And we're still at 360 milliamps, so it hasn't fully gone to sleep from when I woke the bus up. But what's nice is you can have this going on a computer. I did this the other day, and it's graphing your draw, and you can go to work on another car and just glance over at your laptop screen or wherever, and just a quick visual, because this graph's going. It's like, nope, no draws, just keep on working. You just keep, you know, every now and then you glance over, and is it doing anything? Is it not doing anything? So again, PicoLog, and you can download this for free on the PicoScope website. Great software to do a parasitic draw. So I say again, let me know if I missed anything, I went over anything too fast, recover it. Drop some comments, like and subscribe for me, I'd appreciate it. And let me know what else you want to see. We'll put the PicoScope to work and see what it can do for us and how it can quickly get us to a diagnosis, and a for sure diagnosis where, you know, it's like, well, I think it's got this and this, but we need to dig in. Sometimes you can do these non-intrusive tests and you can see it for sure before you ever tear into a vehicle. So yeah, let me know what you guys want to see, what I might have missed on this explanation. I know I feel like I went through it fast. Hopefully I got you all the information you need to see how to do this and to try it yourself. Again, with those resistors, watch your wattage rating and what amp draw you expect to see. Like I said, I started with that little resistor. I never expected to see 10 amps. The first one I dealt with, if some of you guys have dealt with these, are the utilities where the hands-free module is waking up the bus, and when it did that, I was seeing 12 amps before they came out with that software update to reduce how much draw is coming on. But anyways, it was like 12 amps, and so I was 8 amp resistor. It was rated at 8 amps, and I'm running 12 through it, and they were getting hot to the touch. So you just want to watch out for that. And yeah, that's basically it. So again, drop me some comments. Let me know what you'd like to see. Any kind of diagnostics. Focus on PicoScope for now, trying to get a lot of that information out there. And then we can move into other diagnostics, any kind of electrical diag, which technically is going to be probably PicoScope, but we can compare it to a voltmeter. Like and subscribe, drop some comments, let me know what you like and didn't like. Let me know if I missed anything. Let me cover any information I might have skipped over too fast. Just want to show you guys, different alternate methods of this parasitic draw and the power of doing it with the PicoScope and how much information it gives you over your voltmeter. But again, if I went too fast or skipped over something or something wasn't quite clear, let me know. I can make another video or focus on some specific points of this, or we can do it in the comments and try to clear things up. But let me know what you guys think, and I appreciate it.